Hello everyone, my name is Jiaming. First of all, I really want to thank the school to giving me the opportunity to share my projects. I really appreciate. Let me start with something simple. So today, AI is everywhere. We hear about it all the time, and the platforms like Kaggle, Hugging Face, and Reddit have millions of users. So clearly, a lot of people are interested in AI, but there is a thing. Being interested in AI doesn't mean you can actually use it. So if you look closer, Kaggle is mostly for data scientists doing the computations. Hugging Face is powerful, but honestly, pretty overwhelming if you're not technical. And Reddit has a lot of content, but also a lot of noisy and sometimes even scam. So there is a gap. A lot of people have ideas or problems they want AI to solve, but where they go, who can help them, who can trust, and how to even get started. So I think there's something like we can start to resolve from the campus, just like how Facebook started by connecting students, that we really need a simple, trusted places where people can share AI ideas, try tours, and connecting with others who can actually helping them to move forward. So in short, we need a bridge platform between people and AI. So what we are doing differently here, like a Kaggle does have like 15 millions of users. What we want to do, we want to do the local location-based services, which is LBS. So instead of building another global platform like Kaggle, Hugging Face, Reddit, so we start from a specific places like from campus because the real problems are local. People around you often have the similar ideas, similar needs, similar constraints. And we most likely to trust in each other and collaborate if we have physically connections. So we use LBS to build a local AI network. People in the same areas can post ideas, share problems, and discover others nearby who are working on the similar things. So this making collaborations more real, faster, and more trustworthy compared to the random connections online. So on top of that, we use AI to understanding all this local data. We cluster similar ideas, identify patterns, and detect what we call demand hotspots. So problems that you keep on showing up in a specific locations. And instead of building AI for everyone, we're solving AI for this group of people and in this specific location. So this most important part is we don't just stay online. We can go offline. We can talk to users face to face and helping people step by steps. So the reality is many people are still outside of the AI ecosystems and they need real guidance and not just tools. So for us as students, this is really an opportunity as well, rather than we're looking for or thinking for a good job in incoming graduation seasons. So instead of like we can creating some real jobs for ourselves and making some like a good try in the specific areas. So what we need to move forward. So in the future, we just need a small prototype. So launch the small models, and most importantly, and we can test it and integrate it in school. And this platform can evolve to including like AI agents, community features, and even some simple payment systems. But at this stage, the goal is not perfections. It's learning faster, foreign test and improve faster. So we will measure success not by downloads, not by how many models we build, not by how advanced our technology is actually will be based on how many real users we can approach and how many people we can actually help. How many last mile users which normally can reach online we can approach in the campus with. So at the end of the day, the future of AI is not just about building better models, it's all about using AI actually how to helping our users and then be usable, accessible, and meaningful for real people. So yes, we can, if we start from the canvas and solve this even with a small part of the last mile, I think this is already a meaningful step forward. So thank you so much for your attention. And if you have any problems, you can email me for my students account. Again, thank you. Have a good day. Bye bye.
Hello everyone, this is Vidya Bharati Ramachandran from Vancouver campus, and I thank you all for giving me the opportunity to present my topic on interpretable multimodal machine learning for LMS application, especially on quality evaluation for the content. My work brings you here a framework that analyzes text, video, audio, and images quality of the courses and also provides a transparent, actionable feedbacks for the educator and the lecturers. So what makes me to start with that? Most of the LMS platforms truly rely on the text-based evaluation, and also as a trainer, as a experience, I have my pain point on how to improve my content quality as the scores which we work with this other tools like evaluation tools mostly gives an opaque no feedbacks, so it is not much transparent. So to address these issues, I propose the solution which implement the BERT-based semantic analysis and cognitive load theory along with signaling principle. So the solution actually supports all kinds of content inputs like text, images, audio, and video, as I said before. And why we are using BERT-based semantic analysis in the sense to understand the content in depth, which is in a bidirectional way. It will work in a bidirectional way. So to understand in depth of the content, so that as a based of that, you can bring in the proper feedback. So if it is a single one line of content, the tool can analysis the what maybe the improvement can be done to a particular slide based on the content. So that should be in-depth understanding is needed. So for that purpose, we are using a BERT-based semantic analysis, and also to bringing the pedagogical feedback here, we are using cognitive load theory and the signaling principle. So which is emphasis morely on the content formatting, as well as the highlighting the content which is most required for a learner, and supporting not to overwhelm the learner with the content. So it finds the overloading of the content and helps us to reduce the content and to give the highlighted points for the learners to quickly observe the point. So that is what the basic no requirement of the tool. So we used BERT-based semantic analysis and cognitive load theory and signaling principle, and also the now as actually we are working on the text evaluator tool, which is going to just working on the PPTs and the other documents. And we are yet to integrate, as it is an in progress framework. We are in development, so we are going to include the visual recognition, video frame analysis, and the audio feature extractions, all those things, so that to give a proper feedback for the instructors on their all the content, right? So based on that, we can able to give the open feedback for the trainer or the educator to understand where the improvement is needed for the content, so that the quality score improves. So the key feature is about the multimodal framework, and which uses the BERT and cognitive signaling principle, which gives you the transparent and open result for the educator. And the research, the two major goal of this of this tool is that bridging the gap between the research which is already have, and then and the practical utility of the day-to-day educators, right? So as a need of AI now, so we need to integrate with AI. So that's what the framework speaks about. And to give a seamless integration on the in the application, that means in the LMS application, we bring in the Dockerized deployment so that it supports the cross-platform and the and also gives the seamless integration with the across the systems. And also we tend to give a sensitive security to the sensitive data, and also the infrastructure optimization. So that's why we proposed with Dockerized deployment. So with the help of these things, I can able to bring the framework to achieve the goals on the research excellence and the practical educator supports by bridging your advanced AI with the real world LMS application. Thanks for the opportunity.
Hello, everyone. My name is Urania Rahman. I'm a computer science student with a concentration in cybersecurity and information assurance. And today my talk will be about cybersecurity challenges in AI-driven healthcare systems. Healthcare is the most targeted sector in cybercrime. The reason is straightforward. A single patient record contains identity data, financial information, and medical history all in one place. This makes it extremely valuable for attackers to target. The dominant threat is ransomware. According to the Verizon 2024 Data Breach Investigations Report, ransomware was present in 23% of all breaches globally and affected 92% of industries. In healthcare specifically, attacks have increased 300% since 2015, and we only see that number increasing. Financially, the average cost of a healthcare data breach exceeds $10 million, the highest of any industry. A University of Minnesota study found that in-hospital mortality rates for Medicare patients rose 33% during ransomware attack periods, meaning this directly impacts patient outcomes and not just data. AI makes this harder. Healthcare AI systems require continuous access to large patient datasets to function for diagnostics, predictive modeling, personalized treatment. Every model, every API, every data pipeline introduced into that environment expands the attack surface, and the fundamental tension does not change. The data needs to be accessible to clinicians instantly while also being protected, and achieving that balance is very difficult. So what does a secure AI integrated healthcare system look like? The architecture on the slide to my right outlines this framework. Security controls sit at the top: encryption, access control, monitoring, and threat detection, and they govern every layer beneath them. Below is the AI model layer, then the application layer, the healthcare database, and patient records at the bottom. The approach has 4 components. First, security has to be built into the architecture from the very beginning and not just after the fact. Second, data pipelines need end-to-end encryption at every handoff between the layers. Third, AI-assisted threat detection, using the system's own capabilities to identify anomalies in real time, like flagging unusual access patterns or unexpected data transfers before they become a full-on breach. And fourth, adversarial resilient design. What this means is building models that can withstand attacks, specifically targeting the AI itself. 2 common examples: data poisoning, where an attacker corrupts the training data to manipulate how the model behaves, for example, causing a diagnostic model to systematically misclassify certain conditions. And the second is model inversion, where an attacker queries the model repeatedly to reverse engineer the private patient data it was trained upon. These are AI-specific attack vectors that traditional cybersecurity was not designed to handle, which is why they need to be addressed at the design level. To summarize, ransomware is the current leading threat, and AI just complicates things and expands that attack surface. And the solution, or a probable solution, would be a layered secure by design architecture. Now, this framework already exists. The technology already, we have the technology and the means to accomplish this goal. However, the real challenge is addressing that gap in implementation itself. Thank you for listening, and I hope you all have a great day.
Hello everyone, my name is Benedetto Russo. I am an undergraduate mechanical engineering student, and my lightning talk is about how Claude artifacts have helped me study in my rigorous undergraduate engineering courses. For example, in Physics 2, Electricity and Magnetism, the concepts are not as easy to conceptualize and visualize as Physics 1, such as a water bottle dropping due to gravity. In order to help me visualize electric fields, stuff that happens on a microscopic and less level, I asked Claude to help me create an electric field simulator where I could put down positive charges and negative charges to see how they attract and repel each other, as well as the strength of the electric field lines based on the magnitude of the charge. In my dynamics class, I had a midterm coming up. I wanted to help visualizing like that Physics 2 thing. Wanted to see if I could translate the static textbook solutions, static textbook problems, and my professor's video into something I could easily conceptualize and visualize, much like the electric field simulator I made. Not everyone can visualize, a point mass going up in a loop-de-loop, like a roller coaster. I asked Claude, could you help me visualize this based on some homework problems? And sure enough, it did. I did have some gripes with it at first, such as I wanted the animation speed to be slower or controllable, which it did give me the option to. I wanted the animation to be smoother, which it did let me do. And I was satisfied by the result. You could see the failure mode based on the radius of the loop-de-loop and the initial height of the ball, allowing the animations to showcase that the speed was not enough or the speed was enough to make it to the top of the loop-de-loop and hopefully bring the participants down. It even tells you the angle in theta in degrees of where the ball would detach from the bottom, and the height too. So why did I do this? In a nutshell, I wanted to get a better score in my midterm, which is why I created this homework app that would have once been a senior project for a computer science major, but I digress. I was able to, click through work energy, impulse momentum, rigid body kinematics problem, and have access to a practice exam if I really wanted to, go through the concepts, go through the quiz, go through practice of the homework again, just so I would have the experience under pressure of answering exam-style questions. Because I fed Claude the previous midterms. It could make predictions, and they were sure right, because I did very good on my next midterm. And it just helps me save time too, compared to classical static textbook solutions. Like, why waste time when Claude exists for $200 a year? I know, $20 a month. This was the pricing model first introduced with GPT-4 back in 2023. But as commentators said at the time, I forgot who, it's like having a private jet for the price of a bicycle. So it's 100% worth it. This levels the playing field when you're paying for thousands of dollars in classes. You only have access to one professor, or maybe a TA. There's 100 students just as confused as you. Thankfully in FDU we have small class sizes, but $200 a year to get a personalized AI where you can even ask the AI to make the prompt for you, such as for the spending moment diagram for strength of materials, 100% worth it. You're able to control the parameters of the distributed load, how far across the beam is the distributed load, and you can make realizations from the graphs that output, such as where the shear force is at its maximum, the relationship between shear force and moment, such as the shear force being the derivative of moment, which gives you the aha moments much faster than, static textbook solutions, the old days, the old Shingmadu, all that. So if you have any questions, feel free to try the artifacts out. The conversations I had with Claude is probably enclosed in the 6th or 5th QR code. But take your time. If you have any questions, you can email me at benerusso27@outlook.com or b.russo@student@fdu.edu. But thank you for taking the time to listen to my presentation, and I hope you have a great rest of your day.